Hello. We're ready for our second talk for the day on the data track. And I have James Bowkett with me, who is an experienced professional with more than 20 years doing data stuff. And he's going to share his wisdom with us on the foundations of what makes data architectures resilient and how to make the best out of your data. He's working at Open Credo, a consultancy that provides data platforms and developer platforms for organizations. James, without further ado, over to you to take the stage.
Great, thank you very much, and welcome everybody. I'm glad you could join us. So the title of the talk is the 12-factor app for data. So I'll kind of tell you a little bit more about me and about my experience, and how that's maybe relevant to the talk. So as we said in the intro, my day job is as technical delivery director at a hands-on technical consultancy called Open Credo. So what we do is the three things that it says there, sort of cloud native architectures, platform engineering, and sort of data and data mesh kind of platforms. And the area of expertise that is most relevant for this talk is the data and data mesh solutions. And I've spent about 20-something years of my career just in and around data-centric applications, basically where you draw a database in the middle and you just have loads of lines coming in and out of it. So it's kind of data getting loaded in and data getting pulled out and doing something interesting for it and probably stuffing it in another database somewhere elsewhere. So if I think about that career in data, and I think about all the different kind of, technology is technology. Not many people tell you this, but technology is a fashion industry. Yeah, so different architectures come in and out of fashion. So maybe you've got a Lambda architecture, or you've got a Kappa architecture. Maybe you're doing a medallion architecture, with bronze, silver, and gold, or you're a bit more, even more modern. You've got a data lake and a data or a lake house, or maybe you're one of the cool kids and you've got a data mesh and a data fabric, or a data fabric. So all of those different kinds of architectures, and there's snowflake architectures and star schemas and things. All of those different architectures and everything in between, they all share one modern requirement, a non-functional requirement in the modern age, is that they have to be upgraded in a safe and controlled manner. They need to be deployed quickly, and they need to be testable and well tested. Now, this is what our stakeholders demand of our software, and quite rightly so, because that's what they're starting to get used to. With the advent of microservices and proper continuous delivery, this is what they've come to expect. This is how we deploy modern applications. But the problem that we generally see is that actually we've got these great big databases and these data architectures that sometimes become a problem, become a roadblock to continuous delivery. So how can we add that resilience to our data-centric deployments? So the world is increasingly data-centric. I got this great statistic off the internet, so obviously it must be true. Even if we don't realize it, the amount of data that we're generating. So there's this stat that says each internet user is personally generating 1.7 megabytes of data per second. You think about it, yeah, you're on your phones, you're on Facebook and Google and Maps and WhatsApp, and you've got adverts and this and that and behavioral analytics, and all of this data is getting collated and harvested. If you've ever looked at browse through those cookie policies as to where your data is going, your data on that one page is going to several hundred different cookie providers, and they're all kind of generating data and doing things with it. And who knows what, and that's a subject for another talk, because that can be a scary world. So there's also this other really great quote that I love. It's by a guy called Steve McConnell, and he said that the problem with quick and dirty is that the dirty remains long after the quick is forgotten. Now, hold that in your mind. If you think that the normal operations is going to be dealing with terabytes or maybe even petabytes of data, And maybe if you've got small problems or niggles with that data because you've done the odd quick and dirty fix, and let's face it, everyone loves a quick and dirty fix, and you always have to do it. Sometimes you have to do it, but they have to live long. They have to live long enough. The trouble is with data is that they live longer in that data, because at terabytes or petabyte scale, those small little problems that you're coding around then begin to multiply out, and they sit there, they're set in concrete unless you're going to do something about them. So it's much cheaper, I forget what the theory is, but it's much cheaper to solve bugs and solve issues before it's left the developer's desktop, rather than after it's gone into production and you've loaded petabytes of data, because you're changing data, and all the while that you're changing data and loading more data, your problem is getting worse and worse. It's becoming exponentially more hard to change. So let's focus on doing things right first time if we can. So if I think back to my career, I remember when I first read about the kind of the 12-factor app, and that really helped me mold and helped a lot of people mold how they think about cloud native and server-side development, especially in terms of kind of observability and deployment, you know, one artifact, several deploys, this kind of thing. So we thought, why not have a similar set of guidelines for the world of data-centric applications? A nice sort of book of 12 things that we can think about, we can kind of sign up to, and they're nice and easy, and hopefully they feel nice and familiar, as well as sort of almost like common sense things. It's like, oh yeah, no, I really should think about that. But it's something you can put maybe on a junior developer's desk and kind of go, hey, look, think about these things. These are the things I'm going to be looking for, because they will save your bacon a little bit later. You know, future you will thank today you. Yeah. And as I said before, data heavy applications have always really suffered from dragging this great big database with them. So this is a guide for designing data-centric applications, and also some recommendations for how to approach some of the kind of socio-technical challenges with becoming a data-centric application, a data-centric organization. The 12 factors, I've divided them into 4 areas. Unfortunately, they don't divide cleanly into the 4, so it's a little bit lumpy, so I do apologize for that. The database purist in me would love them to be 3 in each, but I wasn't able to do that, even if I bend my definitions. But I still managed to get 12, so I'm happy from that perspective at least. So diving into the first category then is sort of architecture and design. So the first one on my list is data structures as code. If you're using a structured data store, don't rely on the UI to change your structure. You've got to use tooling. If you do use the UI to change the data structure, you've got no traceability between the data structure shape and any application changes that rely on those. You've got no thread other than you, the flesh and bone in the middle, who did the click ops on the UI. You've got no common thread. You've got no one artifact that you can promote and deploy, because the same piece of manual editing has got to done to the other environments as you promote. You know, there are tools to do this. You know, Flyaway, Skitch, Liquibase, Terraform. Terraform's not brilliant at this, and Terraform's great at many things. But it is at least infrastructure as code. They are good things. Use them. You know, the world has moved on. Everything should be code, not just infrastructure or secrets or anything. Just everything should be code. So for the sake of your sanity and those of your fellow humans, don't make manual changes to the data structure ever. And I like to include server or database configuration in that as well, because the database configuration, things like isolation levels, that can actually change your application behavior. So you want to make sure that is absolutely locked down as well. So you can create an ephemeral container, a little Docker container, which will boot up, migrate the database as code, and the container has come out as the Docker image has come out as code as part of your build process. So it migrates the data structure, logs the result, and then it dies. And it's super simple. It's super simple. And it applies to big data stores, not just relational, because you can take that config and make any config changes as code as well. And there's really no excuse not to do this. And it just creates a mess if you don't. And it's very cheap to do. And as I said before, future you will thank today you. So moving on, append-only data structures. So one thing that I probably should have said in my bio is that my background is in finance as well. Now, finance, is guilty of a lot of things, but we really like append-only data structure. I know we don't have the monopoly on that, and we didn't invent them or anything like that, but actually it's used quite a lot, especially in kind of things like double entry bookkeeping and things like this. But if you have an append-only data structure, it gives you the full history, and it allows you to time travel through that data. What is it that I knew back at, a week ago versus what does the data look like now? Yeah. So something to bear in mind is that the date that the data is loaded is not equal to the date that something happened in the real world. So if you take, maybe it's a transaction, maybe it's a user click, maybe it's something happened in an upstream system, the date you loaded it is not the date that it happened, because also you may want to restate that data. If you're doing an append only, you may want to restate that data that you can actually load the same data for a business date or a real world date. You want to load that in another time because you want to maintain that history, because you allow that time travel going back in time. Now, why is that important? If, say, for instance, so I set up a hedge fund years ago, and one of the things that we do is we wanted to backtest the model, run a simulation. What did I know at that point? Now, if I went back and I changed the data afterwards, if I mutated that data afterwards, and I ran that model scenario again, I'd be then skewing that model based on what the data really is, but it's not what I was able to do at that point. What did I know at that point? And as we move into a world where models are going to be doing everything from ChatGPT to figuring out how best to cook my dinner from my intelligent fridge, the thing is, there's going to be models in everything. So actually getting your data house in order and understanding this distinction between those is going to become really important, because then you get a thing called model overfitting, and then the model is actually kind of weak and brittle around those pieces of data. So if you do have an append-only data structure, then your data always leaves a footprint. So it makes later debugging a lot easier. If you have a new piece of data coming along and you've overwritten the old one, you don't know what the system was thinking at that point. And so therefore, you can't actually then restate that data. You can't do anything with that data. You're like, actually, that piece of information is now lost. So this is another example where future you will thank today you. Now, moving on, optimizing for access and retrieval. Now, the value from data is not just from collecting it and hoarding it. The value is what you do with it. The value is getting that data out again. If there's not, all we'd be doing is we would load all this data and we just stick it in a hole in the ground. There's no point otherwise. If we're not going to get it out, we're not going to do anything from it. There's no value in just collecting it. The value is in actually what you get out of it. Reports, display, aggregation, models. But modeling data naturally is not always the best way of doing easy and quick retrieval. Disk is mostly cheap. So if the data won't change, denormalize that data. I'm talking mainly about relational stores here, but store those dimensions on the fact table if it's not going to change, because that's especially true if you're following the append-only data structures, because then you know what the reference data was at that point. You don't need to keep a separate copy of the reference data and things like that and do expensive joins and stuff. You actually bake it into that row and you've got everything that you need at that point. Alternatively, what you might want to do is provide summary cubes ready for access. Now, the trade-off that you've got for that is that any bugs in that upstream, any data that's coming through from that upstream, will then need refixing in any downstream data cubes or summary data structures that you've created. Now, there are some systems that are optimized for writes, but you still need a plan to get at that data. So you take something like S3. So S3 is everybody's golden child. It's like, hey, we'll take the data out, we'll shove it in S3. Well, awesome, great idea. S3 is a great technology. And you can put Athena over the top to make it look like a database, all good. But you've got to be mindful of the schema of that data underneath as well. You've got to be mindful of how you're going to get that data out again. Otherwise, you've just created a graveyard and you've just sent that data off to its death. So, sorry, that wasn't very cheerful. So I shall move on quickly over to separating data from logic. So this one is a little bit of a this one's a little bit of a sore point for me, because I worked on something that didn't have this, and it can be pretty painful. So we'll spend a little time looking at some examples on this. So one of the things that good software engineers know a lot about is leaky abstractions, and allowing your abstractions to leak out of a certain piece of code or a certain component in your system. So you don't want that. That's a bad thing. Now, separating data from the logic, if you bake those two things together, if you make them intrinsically linked, then that piece of logic that decodes that data has to then be replicated in everywhere that data is read. So let's have a little look. So this is this shares a remarkable similarity to a system that I worked on about 10 or 15 years ago. So it was in SQL Server, and we had some company values, and we had a start date and an end date. So start date was 1753, and the end date is 999, Dec 31st, 9999. Now these were the largest and smallest dates that you could represent in SQL Server 2000, and I want to say 2003. Now, anyone coming along looking at that go, God, that's a really long validation date. That's like almost 8,000 years. Now, is that a bona fide end date and start date, or is it some kind of special value? Now, you don't know from just looking at the data, and so therefore the code doesn't know either. So any piece of code that accesses that needs to have some recollection or some knowledge of what that date is. So the Boolean logic also won't work on the end date column. If it's still valid, if it's still valid in the end of the future, leave it as a null. Null's a good thing, use that. So if you want to get all of the current records, you might put a guard condition in there. It's like, well, where end date is null or end date is December the 31st. So you've already got a little bit of technical debt just in a little bit of SQL there, without even knowing that that's the final value, the special value, the magic value. Let's look at another example. So I've got some contracts here. So as I said, I was a finance guy for a while. So here we've got some kind of contract here. So it might be cancelled because it's in a breach, or it's the contract has actually matured. Now, so in that bottom example, what if both the cancellation reason and the matured date, or the matured, is not null? So if I want to find all of the contract breaches, where the cancellation is a breach, that's great, find that. But then, is that row there, is that a contract breach or a matured contract? Don't know. So that means I have to bake that logic everywhere I'm looking at this. It's another leaky abstraction. And so let's look at another example. So there are many different ways to interpret this particular one of the factors. So consider this. This is a set of trades, and you've got an option in there, and you've got an equity. Now, if you're warehousing trades, you probably want a trades table. That's great. That's a good idea. But the thing is, not all trades look the same in finance. So you might have an option, you might have an equity, and they all have different. They have different qualities. They have different kind of facets of data. Their entity relation model is different. Now, if they're shoved together in the same table, sometimes what people will do will reuse a column for something else, okay? Or it will only be null under certain conditions. So take this, for example. So if you've got an equity, if you've got an option, you'll have some kind of underlier. You'll have an equity or a bond or something like that. You can price, and you can buy at that price underneath. If you've got an equity, you don't have an underlier, because that's not how they are structured. Now, this is a real problem, because I need to know when I'm accessing that if Have I got another slide? No. I need to know when I'm accessing that, what it is that I'm looking at. What is in the instrument type depends on what columns I look at later into the row. Now consider this. What happens if the instrument type changes? I've got to update that data, and I've got to update all the places in my logic. What about if we start trading swaps? What are the new values possible in the instrument enumeration? So it's not just in the database table, that's in the logic as well. And you know what? Swaps are a wee bit more exotic as well. They might need more columns. Now, in a relational database, this starts to play real havoc with the query optimizer as well. So you'll end up with chained pages rather, if you've added to the data structure over time and not reloaded all of the data. So that drags on your performance. A query optimizer will take sampling as to where the data is, as to what the optimal path is when it's trying to find the data. And if it's sparsely populated, that's something like that underlier price is sparsely populated, it's not going to know where the data is. And so your performance is going to suck. So if those values change over time, you'd best hope you can track down the code that generated the value in the first place. But all of these examples mean that you either need to bake some logic into a view or into everywhere that the data is queried. And that's just the path to the dark side, because you've then got to track that down as well, which is painful. Moving on, sorry, I've spent a long time on that. As I said, it's a particular hobby horse of mine. So strongly type your data fields. Now, this is just sort of good discipline, really. You should be strict with the kinds of data you let into your data store, and that allows you to maintain the data quality. If not, it's yet another leaky abstraction. Yeah. So this applies to NoSQL stores as well as stores with schema as well. So what if you store a number in a varchar column or a string column? Yeah. The sorting will be based on your collation on something that's actually within your database, rather than its natural ordering of numbers. Yeah. So it's another leaky abstraction, and worse, that's being controlled based on the char set or the collation of your database as well. So this is especially important if you're going to follow number 12 as well, where you're treating data as a product, because you want people to be able to self-serve and kind of understand and contemplate your data. Now, if you've got that kind of varchar if you're storing a varchar in a string column, you're going to need to convert that column wherever you access it. You may also need to convert it when you join it or filter it. So just be consistent. Be consistent of your data types and your precision across the tables, especially if those are columns that you're joining on. And be consistent with your precision as well. Is it a double? Is it a real? Is it a char? Because otherwise that will leak into your retrieval logic as well. So if we look at an example, so I was talking about sort of stuffing numbers into a varchar field. So that's a string column there, the user ID there. Now, if I've got that table there that has user ID as 5, and we read it as 5, but it's the string value 5, then maybe I've got 3 different processes in 3 different languages here. I've got Duke, and we've got the Golang Gopher, and we've got the Python. Now, each of those pieces of code has to parse that user ID and turn it into a number. Now, that's just code that shouldn't be there. And code that shouldn't be there is technical debt. So because the design choice or the lack of design choice has leaked into all these different code bases, you've instantly created technical debt as soon as you've released that user table with the string column. Yeah. Now, this is a fairly noddy example, but there are other examples out there, and this is just something to be on the lookout for, because what seems like a fairly innocuous thing in a pull request turns into instant technical debt on the part of the retrievers. And also, it means that code isn't behaving the way people expect it to behave either. So that, nobody likes surprises in that way. I'm just looking at time. I'm probably taking too long. Okay, quality and validation. So we're coming up to about halfway points here. Architect for regression testability. So we talked about doing continuous delivery. Regression testing is a prerequisite for that. You need to be able to make sure that you can say hand on heart that the the data that you're pumping out, or the new version of that data is just as good as it was before. Now, there are some ways and means to do that, actually. So making it friendly for regression testability. So let's take a kind of a bit of a fairly vanilla example here. I'm loading some data into prod. Now, if I want to then look at UAT for a new version, quite often what will happen, especially in the banks, is that they go, okay, right, we'll do a dump of prod, or we'll give you the latest backup of prod, which might be last weekend, it may not be the nightlies or whatever it is, and then you run your new version against that. Yeah, it's okay, but you've got to ask for someone else to do something. As soon as you ask for something else, especially in a bank, that will drag on your dev experience and your dev time, yeah? Now, a much better way to do this, so let's reset. So we've got our data coming into prod. Now, consider putting an immutable stream in the place to carry the inputs, you know, maybe something like Kafka. I'm a big fan of Kafka. So if you're using Kafka, you might be able to use Red Panda, but you could use Flink or Pulsar, something that doesn't change. So you can make guarantees about that data. Now, then what you can do is that you can listen in on that data and load it into UAT at the same time. So you can keep your UAT purely in sync with prod. Now, this is great. This means that actually you don't have to wait for somebody else. You've got the data that you need, and then you can even act on that data in UAT and go, yep, this is fine. I know exactly how it's going to behave in prod, and then you just promote to prod. Now, actually, there is another alternative. You can do blue-green straight into prod. Now, that is a little bit more brave and requires a little bit more mechanics. I did a conference talk about that a couple of years ago, so maybe have a look at that if you're interested, or hit me up on LinkedIn or something. But you need to make sure that all of the processes that look at the data understand that there can be a blue version of your data as well as a green version of your data. But anyway, let's not go into that now. This one's really important as well. In the spirit of kind of continuous delivery, is tracking changes in your test data. Now, we all get given a data file and we go, oh, wow, that's great. You give me a data file. I'm going to put some test cases into it. I'm going to bake it into the data, and then I could run it up in a unit test and just check that my code works with all these weird and wonderful use cases that are in my Jira stories. Awesome, the right thing to do. But if you just take a breath, as soon as you are given that test data, check it into source control when it's just clean and it has no changes applied to it. Reapply those changes elsewhere. You know, as you add a test case, if you add a unit test or whatever it might be, as part of that check-in, as part of that pull request, do the changes to the underlying data as well. Because what will happen later in the project, someone will go at the upstream system, they go, right, okay, that data file I gave you before, I need to change the format because I need to add a column into it or something like that. You go, oh, right, cool. That's okay. If you've checked in all of your deltas into source control, it means you can take that new file and you can just apply all of those changes to that. You've got some kind of lineage with that. And it means that actually then you can apply your test cases to a new data file, which will give you extra resilience or extra confidence in your releases later. So switching to a new category, audit and explainability. So we're on number 8. So there's a couple of metadata ones in here. Data cataloging. Now, spreadsheets don't cut it anymore. And there's loads and loads of tools out there. So there's Amundsen, Atlas, Open Metadata. Use them. You know, if you have nothing, spreadsheet is a good starting place, but there's no audit, there's no change control with it. If you use a system like Open Metadata, then you can access that data, that metadata rather, programmatically. And you're then at a point where people can start to search that metadata as well. And then it means you don't have to talk to people. Let's face it, we're techies, we don't like talking to people. So, and because the reason being is that slows us down. Every interruption costs us extra time, doesn't it? So then making sure that people can self-serve, that's a really good thing. Ideally, you want your cataloging tool to support branches and release tags so that the catalog's metadata can be altered as part of an atomic release rollout. So as you promote between environments, you're actually promoting the catalog information as well. You know, really kind of keeping that as one artifact, several deploys. Yeah. Alternatively, what you might do is you might have a separate instance of your catalog for each shared environment. You know, you might have a prod, a UAT, or a dev. This can all be supported by tooling in a CD pipeline or whatever it might be. But you've really got to think about how that rollout works and how that metadata is going to use. Just looking at my notes here. For additional points, track the lineage in your data as well. So it's needed for auditing and compliance. You know, if we're going to have explainability in models, we need to understand why our model was sexist or racist or had any kind of prejudicial behavior. So being able to trace where that input data came from, that's going to be super important. I think that is a really coming that is a coming requirement. And in fact, sort of some kind of law enforcement actually requires that already. So the lineage is more complex than data source A goes to data source B. The field level or even at the row and field level can change as well. So some records, they come from, you know, they're munged together from several data sources, and sometimes they say, oh well, if it's a Tuesday, then I'm going to take the data from data source A, but if it's a Wednesday, I'm going to take address from data source B. So therefore, just saying that data sources A and B go to C, that's not good enough. Your individual records are going to have their own kind of lineage, which this all helps when you need to restate data, because you can walk that tree as well. This is another one that I have another talk on. So if that's something that you're interested in, I can direct you to that. There's some talks on YouTube on this. So please get in touch. And the other thing to note is that the data lineage is not static over time. That might change. So actually your catalog or your lineage catalog will change over time as well. So you need to be mindful of that if you're going to go back, if you're going to do time travel and fixing old bugs. Code traceability. So this one, I've never seen anyone do this properly, to be honest with you, but the data tracing the data that's loaded back to the code that loaded it, that generated it, that's super important. And it's super easy as well. You know, you can't just do it time-based, stamp the records with it. Because you want to be able to then trace that back, you know, for several reasons. Maybe there's a regulatory reason, explainability in models, audit, fixing bugs in upstream systems, covering your ass with downstream systems. Say, hey, look, this came from that lot up there, and we haven't changed our code. Yeah, maybe you want to roll back and roll forward, and you want to see what the implication is of that as well. But it gives you a fighting chance of debugging an issue, because actually the code that's in source code today, in source control today, may not, or most likely will not be the code that loaded it. You know, a few months ago, a few days ago, a few months ago, whatever it might be. So code isn't static, but the data kind of is. So you've got to know what code version was that generated it in the first time. Right, moving on to consumption. Now, so this one is kind of this is all tied into sort of some of the more kind of the data mesh and the data product world of thinking. Is we want to make the domain clear to the reader. We want to separate data from the inside, data that's private to us. You know, maybe it's code metadata, like the code version that loaded the data or generated the data, from data in the outside. Data that other people can access, that we allow them access to, yeah? We want to make that domain clear to the reader, yeah? Because again, we don't want to talk to them at all, unless it's really necessary, in which case, yeah, we'll have a meeting and we'll do something, yeah? But don't disturb me, I'm coding, right? And we want to have policies for both those in data on the inside and data on the outside, you know? Retention periods, because you'll have SLAs to data on the outside, but the stuff on the inside, that's yours, yeah? You want to keep that. Now, one thing is, if you don't define APIs, you know what some people will do? Say, hey, it's okay, let's create a database link. You come in, you can query the data. Now, don't allow external systems directly into your data source. Just don't do it, because if you do, congratulations, you are now married. May you have a long and happy life together. I mean, marriage is a fine institution, as my wife tells me. But between two consenting adults, absolutely. Between two databases, it's absolute hell. Because if you do get married to another system and you allow other systems in, you've got unnecessary, unpredictable load on your platform. You've got a risk of deadlock. It's difficult to audit, difficult to secure, and it's difficult to evolve your own schema as well, because you need to sync your release schedule with their release schedule. And you're like, well, why am I consulting somebody else? I did them a favor, and now my releases are at risk because of them. So no good deed goes unpunished, as if you've ever worked with me, you'll hear me say several times a day. So your SLA guarantees are affected by the coupled system. So just don't let them in. Provide them with an API, some kind of clean API for getting at your data. You want to define SLAs and SLOs for the data as well. You need a kind of a new product mindset to keep yourself honest on those things. And those are SLAs for accuracy and quality, referential integrity, the timeliness. How quickly you're going to publish that data after it happened in the real world. If you ever need to restate your data, what's your time window for doing so? How much time do you need? How much time is critical for your consumers? Because if you bubble that up into an SLA, you can have that conversation rather than you have that conversation beforehand, rather than having that conversation when everyone's running around with their hair on fire. Well, why haven't you given me this data? I need it for the report for the regulators. Oh, well, you never told me that you needed it for them. I said, I can't, it's these guys up here. And so, that's never when you do your best work, trust me. So having that conversation ahead of time, that just saves that grief. And then it also gives you a business case. If you say, well, actually, I need a bunch more infrastructure to be able to meet that, or I need to be able to kind of back this up, or I need to design around it to enable to meet that SLO. That gives you the kind of justification. And you say, well, actually, no, we're not paying for it. Well, actually, that's the risk. I'm not going to be able to meet that SLO. And another thing is, what documentation will you provide? What guarantees do you make about keeping your docs up to date? If you've got this set of customers, you're defining a product, you've got to, then what are you doing about kind of keeping them up to date? Because if it's not up to date, bad news, they're going to phone you up and they're going to talk to you. We still don't want that. Okay. Now, moving on to the last one is to treat data as a product. So this is courtesy of the data mesh crowd, really. This is where it really kind of came to prominence in my mind. Is you want to introduce product thinking for data. It means your consumers will get a decent level of service and quality. How quickly do they need that data? How accurate do they need that data to be? What would be the impact of restating the data on the consumers? So lots of things start to kind of drop out of treating data as a product. Lots of good things start to drop out of that. So, and the more the data is procured by others, the more it'll be relied upon. So the more dependent upon that data will be. And so then the more they will create derived data from that. And the derived data can be relied upon as well. And that is really the path to becoming a data-driven organization. So that's all I have for the 12. I have a little recap slide here for all of those there. But I'll probably leave that there. But actually, has anyone got any questions? And by all means, please do reach out on LinkedIn. I'd love to hear your feedback and comments. But yes, if you've got any questions, then we can answer them. If not, I can give you some time back and give you a chance for a coffee before the next session.
Thank you for the great session, James. I found it, like, as an operations person, I love hearing about how to make things more operable. So one question from me is, do you think the people who design these systems and who have to make these decisions are the same people who then suffer from the consequences of whether these 12 principles were followed or not?
Oh, it always depends from place to place, really. You would hope. I mean, if you take a lot of the big tech, people like I was reading a book by the engineering. I think it was VP of engineering at Stripe recently, and he kind of said, well, look, if there's pain in the system, let's remove that toil, and the only way that we're going to make that economic, if you like, is by the people that design and build the system actually supporting it for a bit. Maybe there's some kind of warranty period before it gets handed over or something, because they need to feel that time. They need to feel that pain, rather. And I think nothing stops people from feeling that pain or doing something about that pain than being got out of bed at 3 a.m. I think that's kind of important. That kind of I hate the phrase, the kind of eating your own dog food, because it's there's a nicer phrase, drinking your own champagne. But I think in this case, you want people to eat the dog food because you're like, actually, they need to feel the pain and actually say, well, that was a quick and dirty fix, and the quick's forgotten, but the dirty's still there.
Yeah, exactly. Because I love this quote by Kurt Vonnegut, that one of the problems with the world is that everybody wants to create and nobody wants to do any maintenance. And what you're talking about here is exactly that more maintenance-y kind of thing, like how to think in perspective about the way you're architecting systems so that down the road you prevent problems that will require reactive support.
Yeah.
And go on.
Well, I was just going to say, and I think actually some of these, I think that feeds totally with what you're saying as well, because some of these you want to avoid the maintenance. So let's just not be lazy, right? Like, programmers are the most lazy people in the world, but you want to be lazy in the right way. You want to be able to push a button and the script does all the stuff. You don't want to be lazy and sloppy. You want to be lazy on a beach.
Yeah, exactly. So the architecture maybe is going to require a little more time to do, so that you have less time to operate it after. I'm really interested in your experience with data as a product. Do you see a lot of organizations adopting that, or is this still relatively new as a concept?
Actually, I think it's kind of old. Actually, sorry, don't tell ThoughtWorks.
Okay.
Because there are lots of places, that have been doing that for a long while. So, for instance, so places like people that sell data for a living, people like Reuters and S&P and Bloomberg and things like that. They wouldn't be those data powerhouses if they didn't have some kind of product mindset. They might not call it that, but they will have that data cataloging. They will have that kind of that.
I think you're right, but I'm talking more around like people are starting to look at their own data and creating internal data lakes and things like that. And if you're a large enough organization, data as a product makes a lot of sense, and the whole data mesh construct. But do you see people who are not in the business of selling their data implement data as a product?
Yes, I do. Yes, we've done that with one customer at least that I can think of off the top of my head. And what they wanted to do, they wanted the shiny stuff. They wanted to do machine learning and models and things like this. And we said, look, you're only going to scale to do that. And they had lots and lots and lots of developers and lots of data scientists. They were out in India, so they had a very big development center. And we said to them, hey, look, let's do this as a data product, and then people can self-serve in that data. And they were like, yeah, cool. That makes a lot of sense for me, because if you don't have some kind of way of self-serving, people coming to get your data and doing self-service on it, it is going to drag on everybody else in the organization. I've seen it where people are doing extracts and they're doing 5 different extracts for 5 different consumers, and that it's like each extract is some kind of snowflake kind of thing. Sorry, not in the database sense, but it's an individual sense, and it just drags on the productivity of the dev team as well. So I think the data product mindset is a fight against that, definitely.
Yeah, and it makes a lot of sense, even if you're doing it for internal use. It's just a very good practice. Okay, I see that we're running out of time, so we can give a few seconds back. We also had a comment from one of the audience. Great session. So people have enjoyed it at least as much as I did. So
cool.
thank you again for the lovely talk, and have a great day. Bye.
That's great. Thank you, and thanks to everyone that watched the video as well. Cheers.
Cheers.
Thanks.